In this video, we're going to have a look at the braking force worksheet that we've been using in our shop classes. I just want to run through it quick to make sure that everybody is knowing exactly what's expected with this one. The numbers I use, I'm just going to make up. Of course, you're going to do measurements on your own car and come up with your own answers. But I do want to run through it, and I do want to talk a little bit specifically about the last things when we're calculating braking force for the front and rear of the vehicle and total braking force for the vehicle, just to make sure that everybody's cool with what we're doing. So, I'm going to bring this in so we can have a look at it, and let's break down what we're looking for. Now, I've gone over this in pencil. It's usually a little bit neater than this, but it wasn't very dark, so I just wanted to make it a little easier to see. And this is just a reference picture we got here. Right? So the first thing it asks us to do is to measure the brake pedal lever, mark the fulcrum, and load with the prospective measurement. So they've given us this as a reference. We're basically going to do exactly the same thing. I'm not even going to make it look quite this nice, and you don't have to either, so long as everything we need is present. Up here, they've given us a mechanical advantage formula. This is the same formula that we've been using. They've just identified the measurements a little bit differently. So what I'm going to do here is just kind of put my own terms on here because I don't like when things change. That's just me. So here we have D1, what they're calling distance 1. Distance 1 here from the fulcrum to the point of output. I would call this the load arm. So I'm just going to go ahead and scratch that out and go LA. D2 is from the fulcrum to the point of input, which we know as the effort arm. So I'm just going to do that. And now we have consistency again, and everything is right in the world. So if all I need to do here is identify a fulcrum. There's the lever. Put a pedal on it. Right? Pick an an output point, and a push rod. Right? So all I want you to do here is label the fulcrum, label the output, and label the input. Then I want to get you with a tape measure to get to your own car, get under the dash, and just take the measurements. So again, we're going to do just easy measurements. Today, let's make this, 14 inches. And of course, we're going from the fulcrum to the input, so this is going to be my effort. And then we'll go from here to here. Let's make this 4 inches. From that point to that point. So from the fulcrum to the output, that's going to be my load arm. It's going to ask us if this is a class 1, class 2, or class 3 lever. You guys can figure that out. You don't need me to tell you that. And the next thing it says is to measure and record the length of travel that the pedal has. So the way that I would do that is with the pedal at its resting height, I would go down to the firewall. So I'm just going to draw that in like this. Shade it out. And then I'm going to take a tape measure, and I'm going to go from the firewall to the pedal. That's my tape measure. Now, I would do this with the car running so that the booster is active, because if not, your pedal, you're going to get one good range of motion here, and then you're going to get a little less, and probably by the third one, you're going to have significantly decreased pedal movement because you won't have the vacuum assist. So fire the car up, and basically just take a look here where it is with the pedal at its resting height. Just for the sake of argument, we're going to say this is at 10 inches. Then push the pedal down and see where it ends up at the bottom, right? So let's say that now we're at 5 inches. Subtract this number from this number, we'd have a total pedal travel of 5 inches. That's all we're looking for there. Okay. The next thing it asks us to do here is, in the question, it says a typical stop uses about 10 pounds of force on the brake pedal. An F1 driver coming off the straight can apply as much as 350 pounds. Calculate the force applied to your master cylinder in these conditions. So what we're going to do here is we're going to take these two amounts of force, and we're going to use this as our input. We're going to have to calculate our mechanical advantage, and then we are going to multiply both of these numbers by that mechanical advantage. So if we look back at our example here, we've got an effort arm of 14 inches, a load arm of 4, we know that to calculate mechanical advantage, our formula is going to be EA over LA, which is 14 divided by 4. So 14 divided by 4 gives us a 3.5 to 1 mechanical advantage. So now that we know that, we can figure out how much force is going to be applied to our master cylinder. So the first thing we're going to do, I'm just going to slide this up a little bit, is we're going to take our first number here, and we're going to calculate the output force. So output force equals input force times MA. So for our first example, output force, we'll call this output force 1. Okay, this will be 1. This will be 2. Output force 1 equals 10 pounds multiplied by 3.5 equals 35 pounds. Right, so that's going to be acting on the primary piston of the master cylinder in that first example. In the second example here, we're going to go output force 2. Same formula, different number. Right, so we're going to go 350 pounds multiplied by our mechanical advantage of 3.5. So 350 times 3.5 gives us 1,225 pounds. And that's all we got to do for that first part. The next thing it asks us to do here is to disassemble the brakes and record the diameter of the front and rear caliper pistons. Identify the number of pistons, and then using our area formula, pi r square, we're going to calculate the area. So we have to disassemble them now. At this point, we're going to pull the calipers off the front and rear, and depending on what type of brakes we have on the back, we could also, of course, have drum brakes, right? Then we need to do wheel cylinders. So that's not an option on here, but we're going to add it. So let's just assume that I have something with fairly basic brakes. So we're going to say a floating caliper on the front with a single piston. Let's say we're working on a Toyota Corolla or something like that. So on the front, it's going to be a single piston. So I'm just going to write single here. And then I'm going to measure it. So let's give it an average measurement. Let's say that it's got a diameter of about, let's say, we'll write it all down up. Here's a little piston diameter of 3 1/4 inches. Okay. So we know in order to do this, we need the radius. The radius is half the diameter. So 3.25 divided by 2 is going to give us 1.625. So this is the diameter. I'm just going to put radius equals 1.625 inches. And that's what we're going to work with. So we're going to use our formula, pi r square, 3.14 times 1.625 times 1.625, and that's going to give us a surface area. Let's see what we got here. Back to the dollar store calculator. 1.625 times 1.625 equals 8. We're going to call that 8.29. 8.29 square inches. And so that's what we're going to put in here. If we have disc brakes on the back and it's the same style, we're going to do the same thing, right? Now, if this were a multi-piston, so if this were, say, a fixed caliper with 2 pistons, one on either side, right, we would do the same thing, right? All we would do is we would measure one, we calculate the area. We just know that when it comes down to the last part here, we're going to have to multiply what we end up with for force by the number of pistons that we have. On the rear, this could be single or multi-piston again, or we could also have drum brakes on the back. If it's drum brakes on the back, of course, we're going to be into wheel cylinders. So I'm just going to say you can add that in here. So in this case, if we're talking about a Corolla or something like that, we are going to have drums on the back. So I'm just going to put wheel cylinders. Now the wheel cylinders, of course, the pistons are going to be a lot smaller, right? It's not going to be anywhere near the size of the piston on a caliper. So let's just use the example of, I don't know, let's say 13/16 of an inch. So we'll convert that to a decimal. So 13 divided by 16 gives us, let's call that 0.81, well, it's 0.8125. so that we'll use that as a full decimal here. So I'm going to go down here for this calculation. We're going to say wheel cylinder piston diameter is 0.8125 inches, 13/16, right? We're going to have to divide that by 2. And that's going to give us let's call this 0.41, just to keep it to reasonable numbers here. So we're going to do our same formula. Pi r squared, 3.14 times 0.41 times 0.41, which is going to give us an area of, let's see what that works out to, 3.14 times 0.41 times 0.41 equals, I'm going to call that 0.53 inches square, and that's what we're going to have here. Now, the next thing that we're going to do is attempt to find the size of the master cylinder piston and record it. Right now, this is going to be something that's very difficult to find in a lot of cases. I would be surprised if a lot of people were able to find it. So what we're going to do here is we're going to say not applicable, because I did actually look in all data and try to find this and was unable to. So if no spec is available, we're going to use our 0.75, so our 3/4 of an inch. We're going to calculate the surface area for that one. So 0.75 divided by 2, you get our radius, gives us a radius of, I'm just going to put right up here, radius equals 0.375. And if we do our calculation one more time, pi r squared, 3.14 times 0.375 times 0.375 to give us an area of, let's check it out, 3.14 times 0.375 times 0.375 gives us 0.4415. So let's call that 0.44. And we're just going to put it right in that blank there. We're on the last page of the assignment here. And what it's asking for is it says, using all the info found or provided, calculate the clamping force at A, the front, and B, the rear calipers, at both the above brake pedal forces, so at the 10 and 350, and we did our calculations for those already. Finally, find the total clamping force of all 4 wheels combined. So what we're going to do here is we're going to do the math for the front and the rear wheels. We're going to take a step back and we're going to look at a little bit of system operation before we calculate the bottom. Because I think if anyone's going to get confused or spun around here, this is probably the page that it's going to happen on. And I think the problem is we've got a little bit of theory missing because we haven't quite got there yet. So let's have a look at this. What we're looking for is the output force at the front calipers first, right? So it's a force. According to Pascal's law, we need to know the pressure and we need to know the area. The area, of course, will be the effective area of the caliper piston, which we know because we've already calculated it. We don't know the pressure, right? So to find the pressure, what we're going to have to do is take a force and divide it by an area. And in this case, the force that we're looking for is going to be the resultant input force with the mechanical advantage that we've calculated with these two. And the area is going to be the master cylinder piston, right? Because we're looking for system pressure right now. So what we're going to do is we're going to start with system pressure. So we're going to call this step 1. Calculate system pressure. And a pressure is a force divided by area, right? All we got to do is cover that up, and we know that. So what we need to do here is go back to our first page. And we need to know what our output forces were. So I'll just bring the page back over. And our output forces were 35 pounds at 10 pounds of pedal effort, and 1,225 pounds at 350 pounds of pedal effort. So those are the numbers we're going to be using here. Right? We also calculated our master cylinder area down at the bottom at 0.44 square inches. So if we plug our values in here, we're going to go pressure 1. We're looking for 2, right? Equals force 1. I'm going to put this as force 1, that's the 10 pounds. And this is going to be force 2, 350 pounds. Divided by area. Area is not going to change because it's the same master cylinder. Go to the next step. P1, according to our first page, we calculated that at 35 pounds. Divided by area, which was 0.44. P1 equals 35 divided by 0.44 gives us a line pressure of 79.55 psi. So there's my system pressure at 10 pounds. Now the nice thing about that is, now that I know this, I can make a little note up here. That pressure is not going to change, right? So if I have 10 pounds of pedal effort put in by the driver, right, when we get down here, it's all going to be the same, right? Because it's the same everywhere in the system. Next, we might as well calculate the second pressure. So we'll go P equals F over A again, right? That's not going to change. Now we're looking for P2, right? Pressure 2, when the driver puts in 350 pounds. And it's going to be force 2 divided by the same area because it's the same master cylinder. We take that out. P2 equals the force that we calculated, which was 12.5, divided by 0.44. P2 is going to give us, let's try that, 1225 divided by 0.44 equals 2,784 pounds. I'm going to say 0.1 because it's 0.09. So we're going to go 2,784.10 psi, and I'll make a little note up here. P2 equals 2,784.10 psi. Okay, so now we know our system pressure at both of these operating conditions. Step 2, we're going to calculate the output force. Okay, so we're looking for a force now. It's going to be a pressure times an area. So I'm going to say output force 1, okay, here, we're going to use P1 for that, equals P1 times area. And now here we're looking for the output force of the caliper piston, so we're going to use the area, or the effective area of the caliper piston. We carry that over. Output force 1 equals P1, which was 79.55, multiplied by our piston area. Now our piston area, we calculated out on the first page, is 8.29 square inches. So our output force 1, we do the math here, 79.55 multiplied by 8.29 gives us an output force of 659.47 pounds. Under the first operating condition. Then we're going to calculate output force 2. Same formula, but we're going to swap in our P2 value, right? Because this is when we're pushing on that pedal with 350 pounds force, applying our mechanical advantage to get a much higher output, obviously, and then we're going to have our resulting system pressure here. So we're going to go P2 times the same area, because we're still using the same piston. So output force 2 equals P2, which is 2,784.10, multiplied by our area again, which was 8.29. 2784.1 times 8.29 gives us a very large number, 23,080. It's 189, so I'm going to call that 0.2 pounds. So there's our clamping force for one single caliper piston at the front, right? Now, it's going to ask us again for the total when we get down to C, so we're going to have to multiply this to get the first front, or to get the total front clamping force, but let's move on to the rear for a second here. So down here, we don't have to do step one because we've already done it, right? Our pressures are going to be the same because our operating conditions are going to be the same, right? The pedal doesn't change, so the mechanical advantage doesn't change, and we're using the same master cylinder. So we've already done a bunch of the work here for us. So what we're looking for is the output force here. So I'm just going to put a little note here. Because we have already found the P1 and P2 values, we can start with output force. Okay. So the force again, pressure times area. So we're going to go output force 1 equals P1 times area, right? Same formula, but our area is going to change because we're talking about our wheel cylinders now. So output force 1 equals P1, which is our 79.55 psi, times our wheel cylinder piston area. So we got to go back to our first sheet, and we had 0.53 square inches. So output force 1 equals 79.55 multiplied by 0.53 to give us 42.16 pounds. Then we're going to do output force 2. There's another step we're going to have to do here, but we're going to do the force calculation first, and then we'll come back to it. And output force 2 is going to be P2, which we know, multiplied by area. And again, it's the wheel cylinder area that we're using. So output force 2 equals P2, which is 2784.10 multiplied by area, which is not going to change. That's our 0.53. So our output force 2 is going to be 2784.1 multiplied by 0.53 equals 1,475.57. 1,475.57 pounds. Now, what we have to do here is multiply both of these numbers by 2. And the reason is a wheel cylinder has 2 pistons, not a single piston. Whereas up here, we were dealing with, excuse me, we were dealing with a single piston in the caliper. So to do the front, we'd have to multiply it by 2 because there's 2 wheels. But in the back, each wheel cylinder is going to have 2 pistons. So to get the output force, right now we've only got half of it. So I'm just going to put a little note down here. Because this car has rear drum brakes, the output force numbers need to be doubled. This is because each well cylinder has 2 pistons. So really, what we're going to have to do here is multiply it by 2. So we're going to go 42.16 times 2 gives us 84.32. And that'll be our final answer there. And then we're going to have to do the same thing here. 1475.57 times 2 is going to give us 2,951.14. So 2,951.14 pounds. And that'll be our final answer there. Now the last thing we want to do is do the total. So to get the total, it's actually fairly easy. All we're going to do is we're going to take the total front and the total rear. We're going to add them together, and that's going to be the total braking force. But what I want to just do here for a second is go over the operation of the braking system. So I drew a little picture here. Up until now, we've been looking at like a single kind of piston master cylinder, which is not the way that it actually works on a car today. Okay, so in 1967, they mandated that all cars had to have 2 split brake channels. Right, prior to 67, master cylinders could have a single channel that controlled all the brakes. The problem with the single channel is, if we go back to think about Pascal's law again, right, a force applied to a confined fluid will transmit undiminished and with equal force on equal areas and at right angles to them. And there's that pesky confined fluid thing, right? So if we only have a single output and a single channel, if we have a leak in a brake line, right, we no longer have a confined fluid, which means we don't have pressure in the system anywhere, which means we lose all of our braking. So once we went to a dual tandem, which is what this is called, a dual tandem master cylinder, and a split braking system, so 2 separate channels, the idea here is within the master cylinder, there's 2 pistons. There's a primary and a secondary. Now, this isn't 100% accurate, but it's basically the layout. The primary is going to create pressure for the primary brake circuit. The secondary is going to create pressure for the secondary brake circuit. If one of these circuits fails, right, if let's say we blow this line right here, we won't be able to maintain hydraulic pressure in here anymore, and this piston is going to basically bottom out, and that's going to be the end of it. But this guy can still work, right, because these 2 guys are going to be, the primary and the secondary piston are kept separate by a series of seals inside, which we'll talk about in the class. Also, you'll see in here what I've drawn, maybe poorly, is there's a spring on either side, and there's a rod on this one as well. So how this works is we step on the brakes, right? We get our mechanical advantage. The force is applied with this output rod, which acts on the input push rod, pushing on the primary piston, the master cylinder. This creates pressure in this chamber. The pressure works on the back of the secondary piston, and that creates pressure in the secondary chamber. If we were to lose pressure in the primary, right, and all we were relying on was the hydraulic pressure to apply the secondary, well, then all of a sudden our split system becomes redundant, right? So the function of that push rod that's in there that isn't totally contacting at this point is if we lose hydraulic pressure here, this guy is going to fly forward because there's no hydraulic pressure to hold it back anymore, but that push rod is going to mechanically contact the back of the secondary piston, and it's still going to allow you to apply the secondary brakes. Okay? Now, there's 2 different types of split systems. There's what's called a front-rear split, and there's what's called a diagonal split. I've drawn a front-rear here. This is something that we would see in like pickup trucks and rear-wheel drive vehicles typically, where the primary circuit controls the front brakes, the secondary circuit controls the rear brakes. Most front-wheel drive cars are using what's called a diagonal split system. So in that case, you would have, let's say, the left front brake and the right rear brake would be on one channel, and the right front and the left rear would be on the other channel. So it could be either, but typically, kind of the classic thing was front rear split for rear wheel drives, diagonal split for front wheel drives. Anyways, so now what we have to do here is we're going to look at our numbers, we're going to look at our pressures, and we're going to see how this is all going to work, how the dynamics of this system is going to function. And it's just, we're doing this fairly quickly so that we can understand that final step, right? Why we have to use all the numbers we have to use to get the total braking. So if we had, let's just use the 10 pounds input, right? So we had 10 pounds input into the pedal. 10 pounds into the pedal I look back at my notes here, netted us 35 pounds output. Right? So 35 pounds coming out of the pedal, acting on the back of the master cylinder. When we applied 35 pounds to the master cylinder, we created pressure. The pressure we created was 79.55 psi. So I'm going to put that in here. 79.55 psi. You'll notice that the piston diameters are the same. Right? Now, 79.55 psi, where did that number come from? Well, it's the input force, right, spread out over the surface area of the piston. Remember, it transmits undiminished and with equal force. Right? So these two pistons are the same. That means the force applying on them is the same. With the equal area, we're going to have 79.55 psi here as well. We're also going to have 79.55 psi acting at right angles on every part of the brake system, right? Everywhere in here, that pressure is equalized. 79.55 acting on this piston, and the same thing here. All happens at the same time. The force is equal everywhere, right? Or not the force, but the pressure is equal everywhere. So the force is being transmitted without a loss, undiminished, on equal areas, and at right angles to them. So when we calculate the total braking force, the total output force for this car, if we've stepped on the brakes, we've created the same amount of pressure on both sides of the system, and we've applied it to every piston that's in the system. So what we're going to have to do is find the output force of this piston, the output force of that piston, the output force of this piston, that piston, and that piston, and it's all happening at the same time, right? So if we look at that, we look at our output force at this operating condition with 10 pounds of input force. We calculated that on the front to be 659.47 pounds. But we're also going to get that over here because these pistons are the same size. Right? You could also just say front caliper piston output times 2. Right? Add them up, multiply it, whatever you want to do. When we calculated the rear, right, we calculated first the single piston, and then we doubled it so that we would get them both. So basically what we can say here is we had 42.16 pounds of output force from this piston. We had 42.16 from this piston, 42.16 from that piston, and 42.16 from that piston, right? So for the total rear, we would want one wheel cylinder piston output times 4. So if we come back to our worksheet, we have a look at our total section, the very last thing we got to do here. What we're going to do is we're going to find the total output at both of those force conditions, right? So we have the 10 pounds and the 350. So what we're going to do first is go step 1. Total braking force at 10 pounds. Driver input. And what we're going to do is we're going to take, this is our output force 1 and our output force 1. We're going to go 6, well, let's make a formula for it. So let's go caliper output times 2 plus wheel cylinder output times 4. Or now we'll do, sorry, times 2. You could do piston times 4, or you could do wheel cylinder times 2. Okay. So caliper output force was 659.47. So we'll say total force at 10 pounds equals, in brackets, 659.47 times 2 plus this guy right here, 84.32 times 2. Total force at 10 pounds equals 659.47 times 2 gives us 1,318.94 plus 84.32 times 2 gives us 168.64. So total force at 10 pounds equals 18.94 plus 168.64 equals 1,487.58. Step 1 answer. Step 2. Total braking force at 350 pounds input. Just going to slide this up a little bit. Okay. So we're going to do the same thing, right? Caliper output force times 2 plus wheel cylinder output times 2. So total force at 350 pounds equals, what do we got in our bracket? So big numbers this time, 23,080.20, 0.20 I guess, times 2, plus our wheel cylinder output, which was 2,951.14 times 2. Total force at 350 equals 23,080.2 times 2 gives us 46,160.4 plus 2,951.14 times 2 equals 5,902.28. Add those together and our total force at 350 pounds is 46,160.4 plus 5,902.28 to give us a grand total of 52,062.68. And we're done.